Welcome everyone. So this is our 95th live stream geometry. We have 4 other people here with me today from all over the world. And today I'm going to do problems from various team selection tests for 2022. So for this year. So one problem from Germany, another from Iran, 2 more from Israel, 1 from Indonesia, and then one problem is, I don't think it's actually a TST problem, but it's part of a training program in Korea for math. So if you'd like to join us in the future on this session, feel free to email me at mgreenb801@gmail.com. It's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. All right, so I'm going to get started here. Can you all see my screen? So I'm going to start with this problem from Germany. We have a triangle ABC with orthocenter H and circumcenter O. And P is some point on the altitude from A. So let me think how I want to draw this. Let's see, did that work? Oh, I forgot to put B. There we go. O is going to be the circumcenter. P is any point on the altitude. So one way that we can characterize H is it's the reflection of this point over BC. So I'm going to draw this point right here, D. So that's an alternative characterization for H. And P is any point on the altitude. So P, we can let this point be P. Then we reflect P over CA and CB. Is that right? That's what it looks like. So I guess that's not very symmetric. I don't know if they meant oh, CA and AB. Sorry, that is symmetric. I got confused. Okay. So Q is this point. And R is this point. And it's probably because the reflections of H over each side also lie on BC. So I don't know if it's, I could draw that later, those later. So Y is a projection of R onto CA, and Z is a projection of Q onto AB. Okay, so we're going to want to draw, I mean, I could try moving this, but let's see. So wherever I move P, this is going to be on that ray where you reflect AD, and this is going to be on the ray where you reflect AD over AC. All right, so I'm going to drop those perpendiculars. If I move, yeah, I need to make these rays. I don't think I could draw a diagram where they're not rays. Whoops. All right, so R onto CA and Q onto AB. See if I can adjust this a little bit so that it's not as close to point A. So maybe more like that. Okay. And so this is Y, and this is Z. I don't know if it's worth drawing this point. Why not? prove that YZ is perpendicular to HO. So I wonder if by using homotheties, I wonder if it matters where point P is, or if we could do some kind of homothety that makes it so it doesn't matter. Let's see. Oops, sorry, I keep hiding the wrong thing. All right. This and this, and I mean, basically these AB bisects this angle and AC bisects this angle, and AR equals AP equals AQ, so we can actually draw this circle. A is the circumcenter of PRQ. And this is cyclic right here. And we want to show YZ is perpendicular to HO. We have a good amount of information here.
And it looks like this can be bashed with complex really easily.
Really? Let's see if we can find a synthetic solution. I just prefer synthetic solutions.
Yeah, me too. I don't know how to use complex.
Oh, really? I've used it a couple times before, but yeah, I prefer synthetic solutions on my channel. So let's see. So I guess one question is, can we show that as we move P, so as we move P, it's really, is this just a homothety about A as I move P? Because then we can let P really be any point we want, right? I think it is, because as we move P, the whole figure is similar to what it was before, right? So P can really be anything. Does that make sense? So what's a good choice for P? What if we let P equal H? Well, actually, I wonder if we let P equal H, then R and Q would lie on the circle. In fact, they would just be the perpendiculars from B and C to the circle. And then would that make it really obvious, the problem? I think it might. Because then R and Q are just the theta of the perpendiculars from B and C to the circle. So basically, this is like a parallelogram here. And OP is OH, right? Because we're letting P equal H. Does that help solve it? I don't know.
It makes sense. Yeah, I think we can use P to be the orthocenter.
Okay. So let me then make, yeah, because F and Z are kind of close together. Let's see if I can make F and Z a little farther apart. Yeah. It's not going to be perfect, I guess, but yeah, we can do it like that. And we want to show YZ is perpendicular to OH, or OP in this case. So A is the center of the circle, and this is a parallelogram. So we can think of, yeah, A. So I was thinking about using like the Pythagoras, like showing y p squared minus yo squared is zp squared minus zo squared. Hmm. So what is OP perpendicular to? Is OP perpendicular to anything special? Could we use Ricard's theorem? So I don't know. Let's see. Because yeah, this is like what you'd get if you used Ricard's theorem and you intersected RQ with BC and BR with CQ. So maybe it's worth drawing these points. And then yp squared is yg squared plus gp squared. So maybe that would help. And so we could kind of get yp squared and zp squared. Oh, and then I wonder if we can kind of get yo squared and zo squared, because if we draw the midpoints of AC and AB, yo squared is yj squared plus jo squared. And jo is half of BP. So that's probably enough to bash it, right? I think a bash would work. Although I wonder if we could do it a little easier. So maybe AJOK is similar to, I don't know if that's true. Yeah, AJOK is similar to YAZF, I think. Actually, maybe not. Actually, no, I don't think that's true. But okay, so we want to show that. Let's see if we can bash this here. So yj squared plus jo squared is yo squared, and then yg squared plus gp squared is yp squared. So if I write this out, it's probably, I know I said I wouldn't do a complex bash, but now I'm kind of doing a Pythagoras bash, but hopefully it'll be a little simpler. Let's see, yj squared plus jo squared minus, just writing it on a piece of paper, minus yg squared plus gp squared. Okay, and then we can kind of use similar triangles. So yj we could say it's ya plus aj. I don't know if that makes it easier. Try something. And like this is a parallelogram right here, right? If we drew these 2 points. So OP is basically a diagonal of this parallelogram. So you want to show YZ is perpendicular to the diagonal of this parallelogram. We have 2 parallelograms here. I don't know if that really helps. Let me go with my original idea. So YJ, so that's YA plus AJ squared. And then JO is BP over 2. And then YG and GP. GP squared. That's a good way to write this. Or we could say YJ is YC minus CJ. That's a better way to do it. D is, oh, you thought D might be a good choice too for P. Okay. One sec. Okay. Yeah, first let's try this. If P was equal to D, let's think about that. So yeah, can we make Y and Z easier? I'm not sure. So yeah, I mean, this is also cyclic, and this is also, actually all 4 of these are really cyclic. What do we know about YZ? Maybe I could try to calculate YO squared minus ZO squared. Is YZJK cyclic maybe? No. Maybe, I wonder if these concur. I don't think they do, but yeah. If we show, yeah, that would solve the problem. If we can show it when P is equal to H, that solves the problem. Because if you move P around, it's just, this whole thing just scales. It's true because this whole figure, RIPGQZAYF, if you move P around, it's just a homothety. So basically YZ is always parallel. Wherever I move P, YZ is going to be parallel to itself. Yeah. Oh, you're welcome. Yeah, I don't know if point F is really that helpful. Guess I'll just leave it there, but can we say anything? OP, it's a diagonal, it's parallelogram. We know that. Are these parallelograms similar? Is G the midpoint of, yes, G is the midpoint of PQ and I is the midpoint of PR, because basically we set P equal to H and the reflection of H over each side lies on the circle. So yeah, that's true. I wonder if these parallelograms are similar. So is YZ parallel to QR? No. So what I was wondering is if we could find a parallelogram similar to this one, but with like a rotation of 90 degrees, and then show. We do anything with Simpson lines? So yeah, so let's see, YI, like maybe it's worth drawing the perpendicular from R to BC, because we know Y and I would be collinear with that. And then same with Q. So YI is going to be collinear with this point by the Simpson line. And ZG is going to be collinear with this. Let's just see if that helps. And we know AR equals AQ. I don't know if that does much. And we want to show YZ is perpendicular to OH. I really want to use I don't know if that's how much. I really want to find like a quadrilateral similar to AZYF, but with like a rotation of 90. So like, can we get a spiral similarity? If we define the midpoint of AP, it is the center of AGPI. Yes, that's true. Because yeah, this is these are all right angles. But yeah, I could draw that in. So yeah, like a homothety. Yeah, like I think you're just using a homothety with ratio half, right? But yeah, that's true. So orthocenter AIG. We could. Let's see.
Maybe you wanna use a lemma about the Euler line. So if you let the midline of triangle ABC, which respect to A, intersects IG at a point,
Okay.
then the line connecting A and that point is perpendicular to OH.
Oh, really?
Yeah. This is just you can prove that that line is the radical axis of circle with diameters AH and AO.
AH and AO.
Yeah.
Okay. So basically this circle and this circle. Oh, because both pass through that perpendicular. Okay, that makes sense. So okay, so then we want to show that AM is parallel to YZ. I kind of like that. Maybe we could do that with like homothety of A or something like that. So I guess we have to show angle FYZ equals FRA. And FRA is YRA, which is YIA. So it's the same as showing that YI. Oh, it's the same as showing that YI is parallel to AF. Interesting. So is that really true? Well, and then this wouldn't that mean this would also be parallel? Hey, Stefan, thanks for joining. So we're on the first problem, and we basically realized that this point P, it says it could be any point so that AP is perpendicular to BC, but we realized that we can reduce the problem to where P is the orthocenter. If we solve it when P is the orthocenter, then we showed that we could solve it in general using a homothety. That is what we're trying to do here. Okay, so we want to show AM. Oh, but this makes it look like AM and R are collinear. I think that's why I'm getting confused. AM and R are not necessarily collinear. It's just hard to draw. I guess I'd have to make it more like this so that they don't look collinear. That looks a little better. Okay, so if we could show YZ is parallel to AM, that would solve it. Sorry, how do we define M again? It's where KJ intersects, was it I? Yeah, how did we define M? So where KJ and IG, KA and IG is where they intersect. So AM is perpendicular to OP. And we want to show AM is parallel to YZ. It's problem only involving Y. How do we do that? If you prove that P lies on the polar of Y, interesting. Then, and if P lies on the polar of Y and Z lies on the polar of P lies on the polar of Z, then YZ is the polar of P. Sorry, let me check that. Oh, okay. So we just oh, but it's not true. P doesn't lie on the polar of Y. That's the problem. It's all right. But I mean, again, we could kind of use homotheties to basically scale this to whatever we want. So I mean, we could use the homothety again. Yeah, I don't know if it'll be much. Let's see. So let me try something here. One sec, guys. I'll be right back. Right, I am back. Orthocenter of AIG is the midpoint of FP. That would be interesting. R and Q, so the orthocenter of AIG is the midpoint of FP. R and Q, yeah, I was thinking about using the Simpson line before, right? So I'm just not sure. Like, yeah, if you take the perpendiculars from R and Q to BC, then this is collinear and this is collinear. I'm just not sure, yeah, what we can do with that. Let's see. So we're saying, let me draw the orthocenter of AIG. So no, oh wait, the midpoint of FP. Midpoint. Whoops, sorry, that's not the midpoint. Interesting. How did you get that? But yeah, Urajan is saying the orthocenter of AIG is the midpoint of FP. So basically the center of this parallelogram. And it looks, yeah, it looks true. So RF is parallel to IT. Oh, that's how you got it. Okay. So yeah, use a homothety to figure out that, yeah, T is going to be the midpoint of RQ. Interesting. Yeah, because this is parallel to this, and this is parallel to this. So yeah, T is going to be the midpoint of RQ. I like that. That's creative. Okay, so we know that. But yeah, do you really think the Simpson line is helpful? I don't know. Yeah, I'm not sure. I think I might delete this because I'm not sure how useful the Simpson line really is. I think it might just become, if you can figure out a way that it makes the problem easier, then I'll drop back in, but I'm not sure as of right now that it does. AF is parallel to TL. Interesting. AF is parallel to TL. That might be useful. Let's see. So let's think about this. I still want to go back to yj squared, like yo squared minus yp squared is eo squared minus cp squared. So so I is the midpoint of PR. So if we took a perpendicular from I to AC, just thinking what that would be like. I think some of this algebra might simplify. So GJ squared plus over 2 minus 8g. So GJ squared plus YG times so what if so yo squared minus zo squared, that's the difference between the powers of y and z with respect to this circle. I'm not sure why I didn't see that. So that would basically be ya times yc minus za times zb, right? So that looks like it might be a little easier. So yeah, yo squared minus EO squared, that's YA times YC minus ZA times ZB. And then for YP squared, is P the center of some circle? Yeah, it's hard to get P as the center of a circle, but let's see. Yeah, I don't think P is really the center of anything special. I like that idea. It's
Did
just
you try doing homothety at P?
a homothety at P.
Yeah, and like scaling everything down by one
By
half.
We have not really tried. I think that might have been what Irajan was saying, but yeah, let's think about that more. So homothety at P. So yeah, the orthocenter of AIG is actually the midpoint of QR. So yeah, let's think about that. So it looks like TNLS is like a parallelogram because actually I'm not sure if that's true.
TNLS is cyclic.
TNLS is cyclic.
Yes, and T lies on IN and T lies on SG.
Okay.
And both we have that LN is perpendicular to IT. Yeah.
All right. So yeah, okay. You proved angle FYZ is the same as OH, the angle between OH and AC. Interesting. Then it's done. So how did you prove that, and how does that finish it? It's interesting. Oh yeah, then it is done. Yeah. Yeah, how did you show that? Because yeah, the angle between FY and AC is 90, so that's solve it if you prove that. FYZ equals FAZ. Okay. Is 180 minus FAB. All right. Yeah. Do you want me to delete M or? Oh, you need L. Okay. And an S we can remove. Okay. Trying to get that segment. Sorry. And an S. Algebra is just so stubborn. All right. Do you want point T? All right. FA is parallel to TL. By a homothety. Okay. Yeah, a homothety at P proves that FA is parallel to TL. Because T goes to F and L goes to A. All right. Angle FAB is the angle. Yeah, FA is parallel to TL. Because the homothety at P takes L to A and T to F. So FAB is the angle between AB and TL, which is the angle between AC and OH. Angle between AB and TL is the angle between AC and OH. Why is because AIG is similar to ABC. Oh, that's nice. That's a good one. And very cool. All right, I like that. That's really nice. Okay. So yeah. So all right. So I'm gonna write this up. So first I'm going to show that we can let P equal H. I'm just trying to think how to write this in English, in words. So by taking a homothety at A, so I'll say for any 2 points P prime and P double prime, P double prime on AH. The figures RPQ I'll say like RPQZY would be similar via homothety at A. Where, let's say, prime, R prime, etc. are defined terms. I don't know a faster way. I don't know a faster way to write this in English, so I think that's good enough. We can therefore assume that P equals Q. P equals H. Yeah. Okay. Then Q and R are the intersections of BH and CH with the circle. Let's just say BP, CP, with ABC. All right. All right. Now, let RY intersect QZ at F. We don't really need that this is cyclic. So let T be the orthocenter of AIG. So I and G are the feet of the perpendiculars from B and so. Then we want to let T be the orthocenter of AIG. it'll show that T is actually the midpoint of RQ. And therefore it's also the midpoint of FP. So, okay. So TI is parallel to YR, or TI is parallel to GP, and TG is parallel to, so yeah. So TI is parallel to GP, and TG is parallel to IP. And that implies T is the midpoint of QR. Okay. And that means T is the midpoint of FP, since FRPQ is parallelogram. FP, FR, what is it? FRPQ is a parallelogram. And then once we know that, then we can, now we're ready to do the angle chase that John mentioned. So I'm going to go into the chat and copy some of the stuff he put. So angle FYZ equals angle FAZ, which is 180 minus FAB. And FYZ is angle FAZ. We're using a cyclic, which is 180 minus angle FAB, which is 180 minus the angle between AB and TL. And that's equal to the angle between AC and OH. And looks like Dat is just joining us. So thanks for joining us, Dat. So we're just about finished with this problem. And it was a really nice one from the German team selection test. So, okay, so since angle FYZ is the angle between AC and OH, then the angle between YZ and OH. So maybe it would be best. So this is the angle between FY and YZ. So I'll write it like this. Yeah, I do. I definitely remember you. So yeah, thanks for joining us again. All right, this is great. So, so this implies that the angle between YZ and OH is equal to the angle between FY and AC, which is 90. And that means that YZ is perpendicular to HO. Yeah, thanks for joining. So yeah, this was our first problem, and it had a really fantastic solution. All right, so I'm going to move on to the next one. So yeah, it's this fact. So AIG is like inversely similar to ACB, and so that means that the angle between AB and TL would be, because T is the orthocenter of this triangle and L is the circumcenter. So this is the angle between this orthocenter and circumcenter and one side.